No, you good? My good sweet children, have me learning, have me teaching, and I'm learning myself. But what happened here, folks, you are hoping the variables match up. You want the du variable here to match that. If it doesn't, that drops to a whole new world of integrals. And hey, it does. But what's the number that needs to be in there? What constant needs to go there? 12. If I put a 12 there, what do I have to put out front?
1 over 12.
1 over 12. And I have the rule. So all I have to do is apply the second rule over there. And I get 1/12 negative cosine 4x cubed plus c. And that's what you hope happens. That's what you want to happen. And that's what's going to happen at the very beginning of Calc 2 in college. It's going to be one of those rules. Now the problem is you have to actually learn all the rules. And those are the 10 trig ones right there. And you can take pictures of them if you need to. And then what I will suggest before the end of this year is you have an integral page. And you know, it's got those on it. Or you can watch the video and get them off the video because we're making a video. But that's the 10. So as soon as you see trig, you see if you can turn it into one of those 10. Are we happy with that so far? Happy? All right. Now, may I erase this one? May I answer a question? Anybody need me to answer a question? Yes, sir.
Why would it not be negative 1 over 12 cosine to the x to the 4th?
What's the u?
What do you get after the 4th?
Look at your rule. Sine u du creates negative cosine u. When you take the derivative of cosine u, you write negative sine u.
Okay.
So, you know, if you take the derivative of that, you're going to get negative sine 4x cubed times negative 1/12 times the derivative of that. So if you want to check it, you can take the derivative of this and see if it really turns it back into the very original. All right? Is that okay? But your question here is good because you're thinking, well, what? But this was the original part. And the derivative of it gave you that on the end. All right. Now, may I erase this little list? Because if you see one of these, you got it on your paper. All right. Let's say I had this. I got the integral secant pi x tangent pi x dx. And anytime I'm writing them down, y'all notice I'm always leaving a little space in front of my dx or whatever because I figure something's going to need to go in there. Look to the right and tell me which rule it is. If I yell when I get to the right rule.
Yes.
Yeah, it's that right there, isn't it? Everybody see it? That's that pattern. Now, if that's true, then what does your u? What's your u in this case?
Pi x.
Pi x. So go over here and write u equals pi x du equals pi dx. Now, this part over here that I'm writing down, you wouldn't write it down for this one maybe. I know your professor in college won't write it down, but if you write it down, it will really help you get in the habit of always writing your u, taking the derivative of it. Some people think they write the u and then they just write whatever's over there. You can't do that. You got to do u, take the derivative of it, and then see how they go together. And here you're going to need a what? Pi. Is everybody okay? We need a piece of pi. And what do you need out front? And then you integrate using that rule. Pretty cool, huh? Yeah.
They killed it.
1 over pi secant pi x plus. All right. Any question on that one? Any thoughts? I'm not going to be mean if you ask a question. Now, I'm going to be mean if you ask a question And then y'all watch me and listen to me. Okay? Somebody's watching the video thinking, he thinks he's important. No, but at least I'm here in front of you trying to help. All right. Now, here we go. I was using this to do some real math, like y'all are going to do in your futures, do some engineering. I'm just regurgitating what's already known to you. I'm not creating anything new. I'm just teaching you what's already known. Okay. Now, if there were a plus sign between those, you could integrate each one of them separately. We already know that. If there's a plus sign between parts, we can integrate each one separately, or a minus sign. But there's not a plus sign or a minus sign. And you can't integrate them separately if they're multiplied together. Now, tell me if I pointed the rule.
Yeah.
Which one?
Cosecant, cotangent.
Ooh, good try, but not quite. Oh, Mr. Evans, there's not a rule up there for that, is there? Okay. Remember when I taught you identities?
Yep.
There is an identity that will turn that into one of the rules over there.
Is that 1/2 sine 2x?
Wow. Okay. Man's a step ahead of us. We're going to put a 2 here, and we're going to put a 1/2 out front. And there's an identity that says, here's the identity, if you have 2 sine theta cosine theta, that equals sine 2 theta. And that's the trig identity that I gave you last year on your purple sheet on the back. Okay? That's the trig identity I gave you on your purple sheet on the back, right there. Okay, I'm making sure he's writing those right. I don't want them with the little text. Okay? So, if I use that trig identity, look what I get. I get 1/2 integral sine 2 pi x dx. Now, do you recognize which rule it is? Yeah. So, when you're approaching trig, you might want to think about this or write this on the side of the page or kind of get an idea of how you approach trig integrals. The first thing you do is you hope it's one of the 10 rules. You always look to see if it's one of the 10 rules first. Then, if it's not one of the 10 rules, you check to see if there's an identity that will turn it into one of the 10 rules. All right? Everybody hear that? And then, if that doesn't work, you're going to have to go to a step that we're going to get to eventually. All right? But that's the first things you want to try. You want to see if it's one of the 10 rules, and then if it's not one of the 10 rules, is there a trig identity that will make it one of the 10 rules? Okay, well, somebody says, Mr. Evans, write in your U. Don't not do that for them. U equals 2 pi x. du equals 2 pi dx. So what do I need out here? I need a what? 2 pi. So I need what out front? 1 over what? 2 pi. So out front, I'm going to have 1 over 4 pi. You make sure that pi is obviously in the denominator. And then when you integrate the sign, you get negative cosine 2 pi x plus c. That page that I gave y'all that was full of trig identities, is for this. This is what you use trig identities for, is to rewrite it into something that you have a formula for. All right? That's the reason we taught y'all all those identities. Okay, I'm ready for my question. I know someone's got a question. Someone's listening to me and they got a question. Somebody talk to me. Tell me something. Anyone?
Okay, I have a question.
Good, thank you.
What, when, like in the U part, how do you decide what part of that you move to the
Okay,
outside?
I'll write it over here.
Yes, and then you
I
take
take the derivative,
Uh-huh.
and I look out, I'm looking at this, and I'm looking over here, and I'm saying, what is in here that I need to put in there? And as long as it's not a variable, I can just put it right in there. Now, if it was a variable, then you gotta move on to the next kind of interval,
Okay.
all right? And for right now, the variables are always gonna match up. And y'all get to thinking they're always gonna do that, and they don't. And there's a way to deal with them. All right, so far so good? Okay, well, got another one for you then. I have the integral tangent squared 4 theta d theta. Is tangent squared on your list? No, it's not. Can you turn tangent squared into something added to or subtracted from something on the list?
1 minus.
Secant squared
Secant squared,
plus 1.
secant squared minus 1. Secant squared 4 theta minus 1 d theta. Ms. Quarles, I was a little mean to you at the beginning of class, and I'm surprised you haven't thrown something at me yet, but you can speak up and be loud. Just watch me after you're loud. Okay. Is everyone okay that we just use the trig what? Trig identity. Now, to integrate that, I did that in green because that's probably even a trig identity that they learned at Captain Shreve. I did that because now I'm going to show you what we got here. Since it's plus or minus, we can do it as separate integrals. It's a good time to go ahead and talk about that. Since it's plus or minus, we're going to do it as 2 separate intervals. Because we don't want the 4 to get involved with this. We just need the 4 to integrate which one? This one, right? By following what I did there. If they're separated by plus or minus signs, you can do them as separate intervals. And that way you don't have a problem with putting the 4 out and then not knowing where to put the 1/4 and all of that. It's a little trick there. Teaching you a little bit of something else in the middle of this one. To do this one, what do you think the u is? 4 theta. So what's the du? 4 d theta. What are you going to put right here? 4. Yeah. And then you get 1/4 tangent 4 theta minus, and then what do you get when you integrate just a plain old 1?
X.
Or x, but in this case you would get what?
Theta.
Theta, because it's d theta. And that's what you took the derivative of to make that work. That's pretty heavy duty there because you've got to recognize a trig identity and then you got to do two separate intervals. Yes, sir.
So when you do the two separate integrals, the c just comes into one c? And
Okay, I'm adding a constant to this one, and I'm adding a constant to the other one. Put the two constants together. Yes, sir, that's exactly right. There's really a plus c at the end of each one, but we're just going to put them together and make them one big c.
Okay.
Yeah. Yeah, he's right. There's really a plus c at the end of each one, and we're just putting them together. That's pretty cool, huh? Yeah. Yes, ma'am. Oh, yes, ma'am. Now, the next one, put stars by this one. Put stars by this one. All right. Integral cosine squared theta d theta. Put stars by it. Put stars by this one. All right. Ladies and gentlemen, 1 minus sine squared won't help you because there's no rule for sine squared and there's no rule for cosine squared over there, is there? Fair enough? Okay. This is a trig identity that if you were in my class last year for pre-calc, I had you write it on the back of your sheet, and I had you put beside it Calc 2, or integral calculus identity. Yeah, I had you write that back. This is the only time you need it. All right, I'm going to write it for you. Cosine squared theta equals 1/2 1 plus cosine 2 theta. Sine squared theta equals 1/2 1 minus cosine 2 theta. And those are the two identities that you're going to use to rewrite cosine squared or sine squared into a rule. And that's when you need them, right here. Write those down, put stars by them, because you're going to need those for cosine squared and sine squared. I just told you the rule for tangent squared, but you don't do it very often. For cosine squared and sine squared, you got to have that rule right there. Can't teach you sine cubed today or cosine cubed because you haven't learned enough other stuff yet. I can teach you this one because it's a trig identity. 1/2 integral 1 plus cosine 2 theta d theta. Now, does everybody realize that 1/2 times all of it, so I just put it out front? Good with that? And since it's an integral of these two added together, do you realize you can write it as two separate integrals? Is that all right? And when you do that, just realize it's going to be 1/2 times both of them. See, it's 1/2 times what I get when I do this part, and then what I get when I what? Do that part. Somebody said you could put the 1/2 here and the 1/2 here. Yeah, you could, but 1/2 times the results. And so we'll get 1/2, bracket. And what are you going to get when you integrate this one right here? Theta. Plus. Now we've got to think for just a second. Is everyone okay that the u is the 2 theta right there? Is that all right? The u is the 2 theta? So what needs to go right here? And so don't put a 1/2 all the way in the front. The 1/2 just goes where? Right there in front of that integral. You're only using the 1/2 for that integral. Is that cool? And then you get 1/2 sine 2 theta And then, as the man said earlier, you're just gonna get a plus C out there, but really you got a plus C plus a plus C. And then you can take half of that C, but that half of that C is still just what? C. Distribute the half, and you've got what's probably in the back of your textbook. Okay? These are special. You're going to do these a lot. Cosine squared and sine squared are going to be used a lot. All right? Because radius squared is used in all kinds of formulas for circles, isn't it? Right? R squared. See? So if the radius were cosine theta, you'd have to square it, and you'd have to work with it in an interval. So cosine squared and sine squared are a lot. And these are the two identities. Yes, sir?
Would it be better to leave it undistributed or to distribute the?
I distribute it, but it doesn't matter. That's your call, whatever makes you feel better about it. I think usually the textbook, they distribute them, but it's not wrong just to leave it just right there. Yes, ma'am?
So when you have cosine 2 theta and you're integrating it to make it sine 2 theta, that 2 before the theta doesn't change, that you just use the regular rule?
Yeah, because that, you talk about,
Right there.
okay, there's your u.
Mm-hmm.
So that's your u, and there's your du. And the rule is cosine u du gives you what? Sine u.
That's not like cosine of a double angle or something? Like.
Oh, you could use a rule. Yeah, you could change that to 2 sine alpha cosine alpha after you were done, but you don't do that.
You don't do that?
No, don't do that.
Okay.
Leave it just like that.
Okay.
Oh, you could use a trig identity and rewrite this. To be honest, you could use a trig identity and rewrite this, but why do it when you've already got it set up looking just like the rule?
Okay. So that 2 doesn't affect the rule.
That is in the u. That's part of your u.
Okay. Okay.
See, that u right there is the reason you're getting that 2 out here. Now, somebody says, if that 2 is going to go away when you integrate it, why do you care? Because if you don't put that 2 there, you won't put the what?
1
Out there. And the reason you know there's a 2 there is because the u is 2 theta. If you take the derivative of 2 theta, you get a what? 2. And that's how you know that 2's got to be there. Because what did I not do in this problem? I didn't go here and write u equals 2 theta, du equals what? 2 d theta. So now I got to put the 2 in there. And I got lazy and didn't do that. So far, so good. Now, I always like doing cosine squared and sine squared. That's 2 you've got to be able to do. That's just 2 that life expects you to do. And you notice I'm using some of these trig identities just to make your life harder. I think there's something else we can do just to kind of make you think. I always like to put this one on exams. And the reason I like to put it on exams is because students that don't recognize the identity spend a long time working this problem. What do you see on the board right now?
The mother identity.
Yeah, that just equals 1, folks. Done. I have seen students actually rewrite that as 1/2 1 plus cosine 2 theta plus 1/2. Distribute all that out, work it out, integrate all of it, start adding it together, and guess what you're left with at the very end after that whole day? Theta. So always watch for when there's a trig identity that makes life easier. All right? That's the reason I gave y'all that big trig identity sheet. It's for this right here. This is the whole reason we did all those. Just so you recognize and see that you've got some of these. I think I'm about done for the day. Y'all's brains are probably fried enough for the week. I've got an assignment, but you can't work all of it yet, but if you are interested in doing a few, well, this might help you. We have covered, this is 5-2 in Lighthold's book. At this point, you now know how to work 19 through 28. That's all, okay? That's all we covered today is from 21 to, can't do that one yet. Yeah, 21 to 28 is all we covered in class today. All right? Because I wanted you to get a good look at it. All right? Can't do the trig over here yet. You could probably do these up here, some of you, but I wouldn't worry with those. But if you want, you're good for 21 through 28. Just work 21, 23, 25, and 27 and see if you get those. Because the answers are in the back of his book. See what you can do. But don't just start anywhere on here. Yeah, I hadn't covered a big chunk of this page yet. We just covered one little section of the page. And you did a good job.